The exact questions on the upcoming digital SAT are, of course, unpredictable, but the same types of questions continue to show up again and again. Here are some question types you're almost certain to encounter on your upcoming exam. Our first question type is what I'm calling
Appositive Imposters.
So we need to first talk about what an appositive is. Let's take a look at this sentence. So an appositive is a word or a phrase that renames a noun, usually the subject of a sentence. So in our example here, my friend Taylor is the subject, and our appositive is a pizza enthusiast because this is another way of identifying Taylor. It is extra information about Taylor that we could get rid of and still maintain the integrity of the sentence. So if I said, my friend Taylor once ate 1,400 pepperonis in a single day, that would still make sense. We would still understand, it's my friend Taylor. That extra information about Taylor being a pizza enthusiast is considered non-essential. And notice here that we have 2 commas. We want to separate our appositive with 2 commas, make a little comma sandwich. However, what if we changed it to pizza enthusiast Taylor once ate 1,400 pepperonis in a single day? Now all of a sudden you're going to notice I don't have any commas. What gives? How come it's not pizza enthusiast, comma, Taylor, comma? Why is Taylor not renaming pizza enthusiast? Well, let's think about it. If we get rid of Taylor, all of a sudden we have pizza enthusiast once ate 1,400 pepperonis in a single day. Sounds kind of weird, right? So in this case, Taylor is essential, and Taylor is not simply added information about pizza enthusiast. It is specifying which pizza enthusiast, because surely there are millions of pizza enthusiasts, if not billions, in this world. Because of that, this is an appositive imposter. It looks like it might be an appositive, but in truth, our full subject is pizza enthusiast Taylor. The first part is sort of a title, and then the second part is the main subject, Taylor. Let's see what this looks like on an actual SAT question. And FYI, for sentence boundary questions, that is punctuation questions, I like to just focus on the sentence with the underlined portion. So I'm going to ignore this. And we have entomologist Heather Grab found that when wild growth near an orchard was cleared, the number of different bee species visiting the orchard decreased. And before I even read that, I could look at the answers here and see that we're dealing with possibly an appositive or possibly an appositive imposter. In fact, B treats Heather Grab as an appositive. But if we got rid of Heather Grab, we would be asking ourselves, which entomologist? Surely there are at least 10 entomologists, if not hundreds or thousands of entomologists, right? There's got to be more than one of them. So we know that B is out. And then what was the rule? Well, if entomologist Heather Grab is the subject, then we don't need any punctuation. So it would be C. Let's look at one more of these. This time I want you to try and solve first. So go ahead and pause, and I'm going to tell you what's going on in 3, 2, 1. All right. So again, I'm going to get rid of this first sentence and focus on the sentence with the underlined portion. I'm also going to get rid of recently just to simplify things. Engineer Frank Berg of Tampa University in Finland. All right. So if you're ever trying to simplify, you could also change really long subjects into pronouns. Urka, I think that sounds like a girl's name. I'm just going to assume it is and say she. She used the chemical compound aluminum oxide. So do we have an appositive like C would indicate, or do we have an appositive imposter and we actually want D? That is the question. Well, let's think about it. And I'm going to get rid of A and B because we have either a comma before, a comma after, but we need that comma sandwich. You can't go halfway. So if it were an appositive, we should be able to get rid of aluminum oxide, right? So if we test that, we have, she used the chemical compound to make a glossy solid. Well, is there more than one chemical compound in the world? Yeah. So we do want to specify that the chemical compound we're talking about is aluminum oxide. So this becomes necessary information, and our answer is D. So again, to test this, if you're asking yourself, which compound, which entomologist, which pizza lover, anytime you're asking yourself which, that tells you it is actually essential, which means no commas. Next up, we have perpendicular lines. It's highly likely that you're going to encounter at least one of these on your upcoming digital SAT. What's the rule of perpendicular lines? Well, it all has to do with slope. Basically, perpendicular means you have an inverse slope. Inverse being not only is it the reciprocal, but it is also negative. So for example, if I had a slope of 1/2, the perpendicular slope would be the reciprocal, which is 2/1, or that could just be 2, right? And we're going to make it negative. So these two would be perpendicular. Perpendicular lines also create a 90-degree angle, which is cool, but not usually what we're concerned about. As you can see here, I put those two slopes in and we've got a 90-degree angle. All right, now that we've established that, let's look at this question. Line K is defined by y equals -17/3x plus 5. Line J is perpendicular, so we know we're dealing with perpendicular. What is the slope of line J? Well, this should be easy, right? We want to flip it upside down, so instead of 17/3, we're going to have 3/17. And in this case, it was already negative, so it's going to be positive. Answer is 3/17. Let's take a look at another one that might be a little bit more challenging. So again, we have perpendicular. We know it's perpendicular. And they're also giving us the y-intercept of the line that we're supposed to get the equation for. When we're looking at slope, I always like to put things in slope-intercept form. So I'd probably just rewrite this real quick as y equals -x. Where am I getting -x from? I subtract x from the left side, and then the y-intercept here is 0 because it would be, plus 0, but we don't need to write that. Sorry, let me make my x a little bit prettier for you. So if we're looking for perpendicular, what would be the reciprocal of, well, first of all, what is it? There's nothing in front of x. We can remember that there's an invisible 1 in front of x if there's nothing in front of x, right? So basically, our slope is -1. What's the reciprocal of 1? Well, 1 as a fraction is 1/1, so it would still just be 1. So really all we have to do is change it from negative to positive. So we're looking for a slope of +1, and they told us that the y-intercept is 3, so we're going to look for a y-intercept of 3. So basically, we want the equation y equals x plus 3, right? If we move the x over in A, it's going to become negative, so that's out. If we move the x over in B, it's going to become negative, so that's out. If we move the x over in C, it's going to become negative, but we're going to change y to a positive, so it becomes y equals x. Ooh, but then the 3 becomes negative, but we want a positive 3. So then D, we subtract the x from both sides. We get -y equals -x minus 3. But for slope-intercept form, we want a positive y. So we literally just multiply everything by -1, and this whole thing becomes positive, which is what we wanted, right? Y equals x plus 3. So our answer is D. Next up, we have a specific type of words in context question that I like to call as used in the text questions. Most words in context questions are going to look a little something like this. We have a paragraph, we have a blank space, and we are filling in that blank space. But as used in the text questions have as used in the text, and you're going to notice there's no blank space. We actually have a word that we are replacing, and we're trying to figure out what does this word mean. So what's the difference? Well, for one, you're going to notice that all of these types of questions will include some sort of literature or poetry, whereas the other questions tend to use nonfiction. What's worse, at least what I think is worse, is that these pieces of literature tend to be really old. And because of this, oftentimes the word that's being used is not a word that we would use in that same way. Or it might be a word that we wouldn't use at all. Let's take a look at this question. I'll show you what I mean. And for these types of questions, you're definitely going to want to read the entire thing and look for context clues. So we have Mr. Brooke had traveled in his younger years and was held in this part of the country to have contracted a too rambling habit of mind. Mr. Brooke's conclusions were as difficult to predict as the weather. All right, so I think I know where I'm looking for a context clue right off the bat. This sentence says that Mr. Brooks' conclusions were as difficult to predict as the weather. What I also like to do with these types of questions, or anytime there's older text, is to change the language to something more akin to either modern language or even caveman talk. Basically, what we're getting here is that Mr. Brooks' conclusions are unpredictable, as difficult to predict as the weather, right? And this might be something that you want to jot down in your notes. I'd probably just do this in my head, but I want to kind of show you what I'm thinking. So I'm thinking unpredictable, right? Simplify. So whatever comes before should lead to this unpredictability. Mr. Brooke was held in this part of the country to have contracted a too rambling habit of mind. Let's try to unpack that. What do we think habit of mind could mean? I'm thinking just like a way of thinking, right? So habit of mind becomes way of thinking. And then we have to think about rambling, right? When I think of rambling, it's when you go on and you're not really getting to the point. So a rambling way of thinking would be unpredictable. So basically, he would have developed, I swear I wasn't looking at the answers, but that was, I was going to say, because you want to come up with your anticipation, like what word would you put? I would say he developed this rambling way of thinking, right? So normally you'd come up with your own word and then you go through and you want to eliminate answers that don't match your word. Restricted, no. Described, no. Developed, literally what I said. Settled, no. So our answer is C. But normally you're going to have a word that's similar to the answer, hopefully, and then you can kind of go off of that. I'm sure we'll see that in the next example. Let's get to it. All right, so here, not only do we have an old piece of literature, but it's a play. Like, what is that, right? Anyway, let's read the whole thing. Have we got to part? I'm afraid so. It is a very painful parting. It is always painful to part from people whom one has known for a very brief space of time. The absence of old friends one can endure with equanimity, but even a momentary separation from anyone to whom one has just been introduced is almost unbearable. Again, I feel like my context is going to be in the last sentence because we have the word but. When you're looking for context, if you can find a contrasting word like but or although, it means that this sentence we're about to read sort of goes against the last one. So this could be a clue. So this is saying, even a momentary separation, so a short time away from anyone to whom one has just been introduced. So basically, a new friend or a stranger. Being separated from a new friend or stranger is almost unbearable, but we should say that the absence of old friends should be easy, right? And then this equanimity word, this is not a word that I'm super familiar with, but we don't need to know what this word means, right? Because we know it's basically going to mean the opposite of almost unbearity. So we can infer that equanimity means, easy or like bearable, doable. And if we look at the definition, sure enough, it means mental calmness, composure, evenness of temper. But again, we don't have to know this word. We just need to look for the context. So what word would we stick in here? The absence of old friends, one can, I would say, get through with equanimity, can get through without any problems. So my anticipation is going to be get through this time. Regret does not mean get through. Persist kind of means get through. Tolerate means get through. And encourage does not mean get through. So we're down to persist and tolerate. Well, what did I mean by get through? Does it mean to persist, like you have to keep going? Or does it mean tolerate, as in like I can handle it? When I said it, I meant to say I can handle it because that contrasts with it being unbearable. So my answer is going to be C, tolerate, because that's what I meant when I said get through. Next up, we have similar triangles. And for these problems, all you need to do is boop the like button. Okay, for real though. So, in a nutshell, similar triangles have the same angles, but they are different in size. What does this mean? Well, obviously, it means they all have the same angles. So, remember, these guys are right angles. If I remember correctly, as I was drawing this, we had an angle of 65 up here, which would mean these guys have to be 25. That way, we have 90 plus 65 plus 25 equals 180, right? So that's the number one thing, same angles. Because they have the same angles, they are proportional. And this is the most important thing you're going to want to remember because this is the thing that's a little bit less obvious. So let's pretend that this guy has a base of 2 and this guy has a base of 6. The base is 3 times bigger on the big triangle. That means all of the sides are going to behave in this 3-to-1 ratio. So if this long leg over here is 5, what's the long leg on the larger triangle? That's right, it's going to be 15. Multiply by 3. If our hypotenuse is the square root of 29 here, what is the hypotenuse going to be for the big triangle? 3 times the square root of 29. So same angles, and they're proportional because of that. Now let's take a look at one of the questions. Triangle ABC is similar to XYZ, and then it tells us the corresponding sides. Basically, A is X, B is Y, C is Z, right? Anytime we have geometry in general, I'm going to recommend that you draw. It doesn't have to be pretty. In fact, I won't use the shape tool. I'll make it nice and ugly just for you. So it's going to tell us that the length of each side of XYZ is 2 times the length. Okay, so it's literally giving us the ratio. The measure of AB is 16, and I'm just going to say this is A, B, C. And I'm choosing this arbitrarily. You know, you could put them wherever you want as long as they correspond on the bigger one. I'll show you what I mean. So here's our bigger one. As long as they correspond correctly, we should be good. So A was X, so this is X. B was Y, this is Y. And C was Z, so this is Z. It also told us that AB is 16, and it's asking us about XY. Is XY corresponding with AB? Yeah, man. They're both the hypotenuse. And it already told us that it's 2 times as big, so we literally just multiply by 2. XY is 32. Makes things pretty easy, right? Let's look at one more of these guys. This one going to be a little bit more challenging. So here, it's not telling us anything about similar triangles, but let's investigate. We've got BD equals 6, and they already drew something for us, which is very kind of them. So I'm going to go ahead and label it. And you know what? Since we have to use scratch paper on the digital SAT, I'm going to redraw this triangle a little bit bigger to the right here. All right, so we have my perfect triangle, and it's telling us that BD is 6 and AD is 8. Immediately, when I see these numbers, I know that AB is 10. How do I know this? 3, 4, 5. This is a common Pythagorean triple. I think that's what they're called. Look for 3, 4, 5, or in this case, 6, 8, 10. You don't have to go ahead and use the Pythagorean theorem if you have this memorized. So memorize those numbers, 3, 4, 5. That ratio comes up all the time on the SAT. Anyway, so I know everything there is to know about this big triangle. What it's asking me is the length of DC. So where is DC? DC is right here. How the heck am I supposed to know the length of DC? Well, if we can prove that these are similar triangles, then we can flip this little triangle on its side and sort of compare it to the big triangle. But first we have to prove it. So let's talk about a cool little rule. If you have we'll call it a giant triangle, and you divide that triangle into 2 smaller triangles like we see here, if one end of the line creates 2 right angles like this, and the other end of the line bisects, that is, cuts through one of the vertices of the giant triangle, so basically cuts through into the corner, then you are, by laws of geometry, creating 2 similar triangles. So that in itself is the proof. So if you ever see that going on, just remember you've got similar triangles. A couple other things to look out for would be the hourglass. So if you ever see something like this, that means you've got similar triangles. Or if you have a smaller triangle that's basically the same exact shape as a larger triangle like this, then you've got similar triangles. So those are some visual cues for you. All right, anyway, now that we've established these are similar, it's pretty easy to see for me, but just in case you're not seeing it, let's imagine what this smaller triangle would look like if we flipped it on its side so that it was facing the same direction as ABD. All right, so hopefully you can see that if we tilted that smaller triangle, if we tilted it to the left, so if we flipped it that way, so it sort of fell down onto its back, it would turn into that triangle. And now we can see that CD lines up with BD. So these two guys are going to be proportional. And we can see that AD lines up with BD. Right. And of course, BC lines up with AB. So now everything's looking proportional. Another cool thing we can do is actually label this because we know that BD is 6, right? BD is 6. And then what does this correspond with? It corresponds with 8. So what's our ratio? Our ratio is 8 to 6. So the big triangle is 8. The smaller triangle is 6. We can simplify this into 4 over 3. So in order to get from the small triangle to the big triangle, all we have to do is multiply by 4 over 3. And vice versa, if we want to get from the big triangle to the small triangle, we multiply by 3 over 4. So our last move here would be the length of DC. So DC is our smallest side, which was 6 on the big one. And we want to go from big to small. So we're going to multiply by 3 over 4. So 6 times 3 over 4, you can just plug it into your calculator if you want, or you can do it like this. 6 times 3 is 18. 1 times 4 is 4. 18 divided by 4 simplifies to 9 over 2. And that is our answer. Next up on our list, we have poetry. Whether or not you like it, you're probably going to end up encountering at least one poem on the digital SAT. I like to treat these similar to the way we treat those as used in the text questions, where we are trying to simplify and translate things into language that makes sense. Because poetry, a lot of the time, isn't very straightforward. Let's take a look and I'll show you what I'm talking about. So first of all, there's really only one thing we need to focus on with these, because they're always going to be command of evidence questions. It's always going to ask us to illustrate the claim. So all we have to do is figure out what is the claim. Lowell, that's our author, Lowell describes an element of nature as an active participant in the experience. So the claim is that the author is describing an element of nature as an active participant in the experience. So really we're focusing on this part here, right? If I were to really hone in on 2 words, I would say active participant. Those 2 words are probably the most important. Let's look through our answers and go ahead and start eliminating, knowing what we're looking for. Through the water, the moon writes her legends in light on the smooth, wet sand. So right off the bat, the moon writing legends? That sounds pretty wild. Like, what does that mean? Can you imagine a moon writing legends? Or is that more something that a human would do, right? We're personifying the moon for sure, and it sounds like she's being pretty active in the experience. I mean, also it's giving the moon a gender, so that feels pretty dang active. Let's just go through and eliminate our other answers to be safe. Softly, the water ripples against the canoe's curving side. So the water is doing an action here, but rippling is something that water usually does, right? So I don't know if that's really the water being an active participant, or like the snow white petals, which drop from an overblown rose. Petals dropping, that's something that's pretty common. Not really an active participant, just petals being petals. But the moon in her wayward beauty is ever and always the same. So here we are personifying the moon and saying that she's pretty. But if we talk about active participant, we need the moon to be doing something. Being pretty is not necessarily doing something. So yep, we can go with A. Let's look at one more of these. Here we've got my boy Walt Whitman. I want to give a shout out to him real quick. And yeah, it's from 1856. So let's try to put things in modern language if we can. Again, we have illustrates the claim. So what's the claim? Whitman suggests that so it's saying that Whitman himself deeply understands the reader. He deeply understands the reader whom he addresses directly. So I am looking for addresses directly as well. Yeah, I'm going to go and circle both of those because I feel like both of those are important. We need to see him directly addressing us, and it needs to give us a sense that he understands us deeply. So we have, your true soul and body appear before me. What the heck does that mean? I would say, I mean, literally he's saying that they appear before him. But I guess we could also say that this means that he sees them, right? If they appear before you, you can see them. So I'm going to say, like, I see your soul. I see your soul. He is directly addressing us here. And to see someone's soul does kind of mean to really understand them deeply. So A feels good. Let's go through and see if we can eliminate the other answers. Whoever you are now, I place my hand upon you that you be my poem. So he is, again, addressing us directly, but in this case, he's telling us that he puts his hand on us and makes us his poem. I don't know exactly what that means, but it doesn't seem like it means he understands us. So we're going to get rid of B. I should have made my way straight to you long ago. I feel flattered. Whitman really seems to think a lot of me, but I don't see that he's understanding me in that line either. He's just like, I like you a lot. I feel like I should have come your way a long time ago. Whoever you are, I fear you are walking the walks of dreams. I don't know what he's saying here. He's afraid that I'm walking the walks of dreams. Maybe that I'm, a habitual sleepwalker, or maybe I just dream too big, but I don't actually take action. I don't know. I have no idea what it means, but that's okay, because I do know that it doesn't mean he understands me deeply. So get rid of D, and yep, A is our answer again. What are the chances? Our final problem type is quadratic functions. And I want to note here that according to the College Board, these questions are difficult. But are they really? I don't think so. Because here's what we're going to do. We're just going to plug this into Desmos. Of course, we should probably figure out what we're looking for first. So let's take a look here. It says, what is the value of t? And then t is going to be an x coordinate. And then it says this is where the function intersects the x-axis, which is x-intercept, right? So basically, we're looking for the x-intercept that isn't 0, because it says one of them is going to be 0, the other one's going to be, something else, t. So now all we have to do is plug this into Desmos, and the one thing that's going to change is that Desmos prefers that we use y. So anytime you have a function, f of x or h of x or p of x or whatever letter you want of x or of something else, anytime you have a function, just change that left side to y so that it looks like this. So now we have our function exactly as it was written, except for we changed h of x to y. 0, 0 is one x-intercept. That's the one we don't want. The other one is 8, 0. That's the one that we do want. So our answer is 8. There it is, 8. Pretty easy, right? All right, let's do one more of these. Once again, according to College Board, this is a difficult question. Difficulty 3, hard. It's the hardest it can get. But this time it's asking us for when does f of x reach its minimum? Ooh, but there's one thing here. For what value of x does f of x reach its minimum? As long as we know what it means for something to reach its minimum, we should be good. And anytime we're dealing with a quadratic, a minimum is going to be the lowest possible y value. Basically, if we have a graph, if a quadratic has a minimum, that means it's a smiley face and not a sad face. Smiley face, right? Minimum, because it's never going to go lower than this point, so it has a minimum. If we saw maximum, that would mean we have a frowny face parabola. And the maximum instead is going to be up here. So it's always going to be the vertex. Basically, it's asking for the vertex. And in this case, it's asking for the x coordinate of the vertex. Fair enough? So once again, let's just plug this into Desmos. All I'm going to do is change f of x into y. All right, so I've done that. Now this is where having a mouse is really handy. I would highly recommend getting used to having a mouse so that you can use it to more easily scroll around. Because here we can't see the vertex, so we're going to have to scroll down. Boom, there it is. Stick our mouse on there, and we've got the x coordinate, 6.25. So our answer is 6.25. Now that you know some of the most common question types you'll be facing, you need some serious practice. At the time that I'm recording this, we are offering free proctored exams featuring the same interface that College Board uses. Just use the link in the description to get registered for your free practice exam right now.